Hi everyone, and welcome to my session Build and Deploy PyTorch Models with Azure Machine Learning. So my name is Henk Boelman, and I'm a cloud advocate at Microsoft, and I'm in the data and AI team. So my job is to kind of help everyone be successful with their machine learning workloads on Azure. I have Twitter, so you can follow me. All the code samples will be on my GitHub, and I have a website with some blogs about how you can actually use our tooling. So what are we going to do in this session? So first I'm going to explain what Azure Machine Learning is, or machine learning on Azure is. Then we're going to train a PyTorch classification model. And then we're going to upgrade that and create a pipeline, and then we're going to deploy it to a managed endpoint. I have 2 slides, and the rest will be Visual Studio Code demos. So let's hope Internet and Azure will work today. So what is Azure Machine Learning? So Azure Machine Learning is not just like that one thing you click and your research will deploy. It is a set of cloud services that work together to help you kind of do the whole machine learning lifecycle, from managing your data all the way up to running your models in production systems. And you can control that set of Azure Cloud Services with a Python SDK and an Azure CLI, dus the Azure Command Line Interface. So you can just type in your terminal and do everything. And that has the benefit that you can actually put those commands in like GitHub Actions and Azure DevOps and other continuous deployment systems if you want to do that. So let's focus a little bit on that set of cloud services. So you go to Azure, you click Azure Machine Learning. What you will get the actual component. You will get storage, you will get a key vault to manage your secrets. You get an Azure Container Registry, so that is a registry where you can manage your Docker containers in. And you will get applications insights. So that will give you some insights about your models, how they run in production. So let's start straight away with Azure ML. So we have a studio for that, so it doesn't live in the Azure portal. You go to a separate website and you type ml.azure.com and you could connect to your workspace. And then you get, like you see here on the screen, a lot of options. So we will go through a few because I can talk about this all day and we only need a few for this demo. So this is your dashboard. On the left you see all the items. So let's start here with the assets. So we have data sets. Here you can register your data, and the data can come from a data store. Your data stores can be an Azure Blob Storage, can be an SQL Server, can be a data lake, and all the other kind of things. We can go here and we can connect to a data store here. We have all the different types you can use. And from the data on those data stores, you can create data sets. And those data sets you can use in your training jobs. Then we have, press the cross. Then we have experiments. Under experiments, we keep track of all our training runs. So today we're going to create a Simpsons PyTorch model. So I have a data set with like a lot of Simpsons Lego figures, and we're going to train a model on that. It's a PyTorch classification model. So my experiment is called Simpsons PyTorch. And under that Simpsons PyTorch experiment, you have a lot of your runs. So every time you try it, you will see all the results there, all the logging, everything is automatically there and versioned, and you can compare those different runs under your experiment. We have components. You can create reusable components that you can later on use in your pipelines. You have the actual pipelines. You have a model storage where you can register your models, and everyone can connect to that model storage and pick the model out, because you have the training part that delivers your model, and then someone needs to write something meaningful around it, so your model actually does something in production. So those people that will write those software can connect to model management and say, hey, give me the PyTorch Simpsons model version 5, and they will, you can use it in your software. Endpoints, this is where you can find your published model. So someone has written some software, some containers, and here you will find your deployed models. And there are different flavors of that. Under manage, we have compute. Here you manage a different type of compute you need. We have our compute instances where you can which you can use to run your Azure notebooks on, or your Jupyter notebooks, your choice. We have our compute clusters. These are actually used to do your training jobs. So here we have Optimus Prime and we have Bumblebee. Optimus Prime is a GPU-enabled cluster, and you see 6 nodes are up and running. So they're there for us to train and instantly available. You can also make your cluster automatically scale, so then you don't pay. The only thing this does is consuming my credit card. Then we have inference clusters. So we can connect Kubernetes clusters, Azure Kubernetes clusters, or remote Kubernetes clusters with Azure Arc to Azure Machine Learning, so we can deploy on-prem in Kubernetes, or we can deploy in Azure, of course. And here you can use it to attach them. We'll not dive into that. Under environments, we can register the environments we can use to train and run our models. We have a lot of curated environments, which are all pre-installed and you don't have to build. But if you need a very specific thing, you can build your own containers and register them there. Data stores we talked about. And we have some tools where you can do your data labeling. One other thing I want to highlight is notebooks. So here in this interface, you can just click on a notebook and actually run them and work in the cloud. So you don't have to go to the hassle to install all those dependencies on your local machine. You can just use one of those compute instances and run your notebook in it. So that, in very short, are the capabilities of Azure Machine Learning Studio. So how do we train actually a job? So I'm going to use Visual Studio Code with a Jupyter Notebook to start training and start prototyping for my model. But I want to run this code all locally, but I want to do the training in the cloud, and also I want to have the data in the cloud. So we'll start with importing a lot of dependencies, because I like to always put them on top of my notebook, but that is obviously your choice. And then we're going to connect to this workspace. So to make this happen, I installed the Azure ML SDK, and then I already logged into Azure. But when you run this command, it will open a browser window where you have to authenticate to your Azure subscription. I'm connecting to my compute target called Optimus Prime, connect to my default data store, and I'm connecting to my experiment Simpsons PyTorch. Next, I need my data. So I'm going to connect to my Lego Simpsons dataset version 3. So we can go back in Azure Machine Learning and actually have a look at what is in that dataset, because you can explore it. It's indexed in 500 files. So you click on it, and then here we see Bart Simpson. And so we have 10 different classes, and every class has around 50 images. So we connect to the dataset. You see no credentials needed, because all the credentials are managed in our Azure Key Vault in the data stores. Yeah. I'm going to use a curated environment because my training script is a PyTorch training script that I just copied from the PyTorch website and then did a few adjustments to. But I will show you the adjustments later. But it is not something very, very, very fancy. So I can just run it in an Azure ML PyTorch 1.10 container. But you can use your own containers and own environments here also. So now I have my environment where I'm going to run it in. So now the next thing I have to do is to configure how to run it. And that you do with a script run configuration. So I tell it where my training script is, and all the other dependencies, where the train.py is, the actual script that it has to execute when the container is spun up, on which compute target I have to run it, which environment, and which incoming arguments you have to inject in the script. This one line makes sure that I can access my data set as a virtual directory in my container. So it automatically mounts that data set for me, and it is available as a directory. And that directory name is parsed into this variable. Training runs. So let's do it. Let's run it. And then you submit your experiment to, or you submit your configuration to the experiment, which will create a new run. And we have a widget here. And it should show running. And now we can follow real time what is going on in that run while our job is training. So while we wait for Azure to kick in, we go back and I will kind of illustrate what is happening underwater now. So we have my local computer here with a notebook. And when I said submit, it snapshotted everything in that training directory. So all the files that are in the training directory, including my training script, is being copied over to the experiment and is versioned there. Then it is creating this Docker container according to my environment specifications. It deploys that Docker container to my compute target, to my cluster. It's mounting my data stores because the data set is on a data store. Then it is launching my training script. And then it is sending back all the metrics through my experiment back to my notebook where I can see everything in my widget. Oh. And then it copies over all the output when it is done to my experiment. So let's hope it is actually running. Yeah. So you see I have 6 nodes in my cluster and 1 is actually busy. And here it is streaming back all the information that I'm logging. Here we see the training loss, we see the validation loss, accuracy, and so on. And it should be almost done. We had said 10 rounds, so with number 9. So perfect, it is almost nearing completion. So in the meantime, we can look at the training script. So I copied the training script from the PyTorch website, and I added these references so that I was able to parse incoming arguments and that I can connect to my run context. And now I'm connected to my run context, I can add some logging. So here I'm logging floats for the accuracy and the loss function. And because this is an array of floats, Azure Machine Learning automatically understands that it has to draw this graph from it. And because this data is real-time sent to Azure Machine Learning, we can follow that graph real-time. So it should be done by now. Yeah, so the job is completed. So now our output is in Azure Machine Learning under the experiment, Simpsons PyTorch, the latest run. This is our run. And we can find our model here under outputs. But this is absolutely not where I want to have my model in my outputs. So I want to register this model in model management. So what I do now is I say model, or from the run, register this model. We can here say Pygrunn, register a new version, so we actually see that it's real time and not a video. So we register it, it prints, and it is registered under the name Simpsons classification dev version 3. You can specify which framework you have used. I actually used 10, but it is a development and presentation. So here we go models, we click on the registered model, and here we see that it is tagged with PyTorch Grun. And we see the same artifacts here, the labels and the actual model. And from this model now, we can go back to the experiment that has created it, to the run that has created it. And from the run, we can go back to the data that is being used. So now we have this whole traceability from actually the model all the way back to actually the files that were used for the training and access to all the log files and all the metrics I've sent. So that is pretty cool. But now I just want to quickly test it. So let's create an Azure container instance where this model is being deployed in. So I'm going to run this cells because we all don't want to wait 2 minutes. We just want to see it working. So to do that, I had to run this cell also. Hopefully it works. Yeah. Okay, it is running. So first I specify again an environment where this script is going to run in this model. And I don't want to have the curated environments because I don't know what Microsoft put in there. I want to know have my own plain image. So I'm starting with adding some dependencies, and that's it. And I'm creating my environment called Simpsons Inference Test. Then I'm going to specify how it has to work in inference configuration. This is the environment you have to do, and this is the scoring file. So what the scoring file has is two methods: an init method where you load the model, and then a run method where all the predictions come in, and you do the inference actually. Then next you specify how your Azure container instance has to look, how big it has to be, how many cores you want, how many memory you want. And then finally you say, model, deploy it, give it a name. This is the model you have to use. This is the inference config, the deployment configuration. And if it already exists, just update it. So you see, this is not great for in production because your model will actually be down for like 2 minutes. But it is perfect if you just want to test it and see if your container is actually be working before you're going to push it all the way through like those production systems, which can take pretty long to deploy. So luckily we see it is deployed, and now I can send a test image to it, Bart Simpson. I say Azure Container Instance Service run. This is my input data. It's just a JSON with a link to an image. And we print the result, and luckily it tells us that it sees Bart Simpson on the image. So we can now go to Azure Machine Learning, go to Endpoints, and see here our endpoint. So now from the endpoint, we can also go back to the deployed model, and then of course obviously go all the way back to the data. We can quickly test it also here by specifying some JSON. We say image, and we have to copy and paste the URL. So let's do that, put it here. So we see that it is here also saying that it is Bart Simpson. And if we change it to Lisa, and hope Lisa is with a capital, yeah, we see that it can also do Lisa and maybe Homer also. And it also does Homer. So it is actually working in the background now and running it in production. So you can test something if you have the code and everything well in, what was it, 8 minutes? You can have a model up and running and versioned all the way. But this is obviously not how you're going to do something in production. Yes? A random name, then it will just break because my code is quite shitty. Now what we'll do, this piece of code in the run method, I can actually show you. This is my scoring. This is the scoring file I've used. This is the init method that loads the model and the label. And then here I'm just parsing the JSON, and then I just run it through whatever you put in. So obviously you need to write a lot of checks here to make it production ready. So never use my demo code in production. Yeah, so obviously this is not how you are going to run it in production. So for that you want to set up like more robust training pipeline. And in Azure Machine Learning you can create those pipelines which are published as an endpoint. So you can, when you publish this pipeline, you can just call an API and it will kick off that pipeline for you. And those steps you create in your pipeline, we call them components, are reusable. So how does one of those pipelines look? So now we come into this where we're going to separate and let the Python SDK go and connect more to the Azure CLI, because we really don't want to mix up how our jobs are running with the actual training part. So what Microsoft did is kind of split that. So we have configuration on how your job has to run in YAML, and then the actual training will obviously happen in Python. So I've used the Python SDK just for prototyping in my notebooks, but now I'm going to productionalize it, and I'm going to separate those two things. So this is how it looks to create a pipeline. So we say, yeah, let's let's actually run it so we can actually see it later on. So what I'm doing here, I'm specifying a job. First, train it, register the PyTorch model, convert that model to Onyx, and then register also the Onyx model. And you see the step I'm using to register a model, I'm actually reusing. I'm going to the components. Not train.py, but the train.yaml. So you saw me creating a script run in the previous notebook. Here I'm doing exactly the same, but then in YAML. I'm just telling how my Python script has to run, on which environment it has to run, where it can find my code. But here I specify also where it can deliver my output. And the outputs you can share between those different steps, like we see here. So we have the output is called train data, train output. We can use that as an input for registering the model. And so we can pass all those things on. So you can add some steps to do some more data preparation, to test your model, and so on. So you can make this as big as you want. So you execute these YAML files with the Azure CLI. So if we can, Visual Studio Code can automatically do that for you, so you don't have to remember it, which is really nice. But if you want to type it, you just say Azure Machine Learning, job, create, you point it to the file, and then you point it to the your resource group, your workspace name, and then you say, here, stream the outputs, but you don't have to do that. It can run somewhere. You don't have to look at it. So notice create, submitting the run, and hopefully we will see that now appearing under experiments. Azure Machine Learning PyTorch from Visual Studio Code. Great kitten, wonderful names. So here we see the pipeline that is created from that YAML file. So we see that takes the input data set. I've pointed it to my Simpsons data set when I submitted it. We see here the training. Then it is going to register the model, convert it to PyTorch, convert it to Onyx, and then register the Onyx model. You can click on those steps. So we can actually read the logging, see what is going on. The driver log is the most important log that actually shows the output of your script. The other logs show all the mambo jumbo that is going on in the background, great for debugging the environment, but not your script. And you see the outputs this step has generated exactly the same as what we saw when we were doing it manual. The metrics are also here, safely stored. And here we see the parameters I've injected into it. Okay, so this is now training. So the last thing I want to show you is how you can deploy it in 2 minutes. Because then the story is quite finished. So we have managed endpoints, and I'm going to quickly pull up a slide to actually illustrate what has happened and what we can do for you there. So we have a client, and so from the client side perspective, you hit an endpoint, and then the endpoint will manage your traffic routing for you. So you can deploy model 1 in like this case, a blue deployment, and then a green deployment you call deploy model 2. And you can say route 90% of my traffic to this deployment and 10% of traffic to this deployment. Those deployments are individually scalable. So you can deploy, you have a deployment and you say, oh, it needs this type of compute under it. You can scale it up between like 1 and 10 nodes and just manage it for me. So what I've done is I have one managed endpoint here for you under endpoints. It's called Simpsons classification. And then I have 2 deployments, one with an Onyx model and one with a PyTorch model. And I'm routing 50% of the traffic to each model. Here we have, we can test the deployments individually. Here is how we consume it with the keys and everything. We have inbuilt monitoring, so you can monitor all the requests and see how it performs. Here we see that the latency, and we have deployment logs. So now, to close off, I will test that endpoint. You just have to believe me that this is the same URL as the actual deployment. And we are going to send BART to it. And we have to do that a few times. So here we see it is using the PyTorch model, the PyTorch deployment. And if I have hit send request enough, we are now at the other deployment where it runs the Onyx model. And so now we can just actually compare times, which of the two models is faster. So this was very short, in 30 minutes, and a lot of things to cover. So all the code is available on my GitHub, Azure Machine Learning PyTorch Visual Studio Code. And then if you have any questions, you can just create a question on my GitHub or Twitter, or just ask them now in the last 3 minutes before lunch. Okay.
Talking about deploying a lot of stuff online.
Yeah.
But I see a lot of files containing a lot of configuration and code as well for the cloud environment, and a lot of work in the train. So I'm just wondering, how much of this can I do on my own laptop in the train?
Yeah, everything. Yeah. I still have to try it, but my colleague, when she writes a demo, she does everything, even managed endpoints you can run locally on your machine. And everything is on docs.microsoft.com.
All right. Are there any questions from the audience? I see one over there.
So what's the feature as well that you do in this in machine learning? Azure Studio Code, right? And also AWS, which is Data Factory, and also Databricks, that's also Microsoft products.
Yeah. Yeah. So how I see it is that the other two tools are really great to get data into this system, and then from there, this kind of system takes it on and does the actual machine learning, the training. Because as far as I know, Azure Data Factory can prepare your data very well. And we actually have steps, like those components, in Azure Machine Learning that connect to Azure Data Factory. So we have Azure Data Factory steps. And to be honest, I never played around with Azure Databricks. These ones scale automatically up and down, but will always use like your minimum configuration. It will not just go away and then you're not be built. If you use GPU for inference, then that will absolutely be your deployment. That will always be up and running. But what I normally do is I pick up the model from model management and then write an Azure function around it, and then deploy my Azure function, which obviously don't cost that much. And that is where you only pay for when you're executing your model. Erwin, do you know that? No.
Last question?
Yeah.
Yeah, maybe. So the endpoints is completely different from the compute instance that you have there in machine learning part. Right?
Yeah. So yeah, they're really separated. Yeah. Yeah.
Since it was short, then we can do
Yeah.
When did you switch from Microsoft to
Ooh. Yeah, that was, I think, the last thing I did in person. So it must be like 2 years now.